Printed circuit boards, or PCBs, are very important. They are essential in almost all electronic devices. PCBs hold all the small electronic parts. These parts are often called components. PCBs also connect these components together. This electrical connection makes the device work. From simple children's toys to complex supercomputers, they form the hidden foundation of modern technology. PCBs matter a great deal for several reasons. They make electronic circuits reliable and strong. They also allow circuits to be very compact. Before PCBs, hand wiring was the common method. This old method was often messy and prone to errors. PCBs offer a neat, organized and repeatable solution. This allows for efficient mass production of electronics, and it ensures consistent performance across many devices. You can think of a PCB like a tiny, flat city. The various electronic components are like the buildings. The thin copper tracks on the board are like the roads. These copper roads link all the buildings together correctly. This careful organization is absolutely crucial for function. It ensures that everything works together smoothly and properly. Without PCBs, our favorite gadgets would be much larger, and they would certainly be far less dependable in daily use. In the early days of electronics, devices were bulky. Wires crisscrossed everywhere inside the casings. This made them very difficult and slow to build. It also made them incredibly challenging to repair if faulty. PCBs completely changed all of that for the better. They introduced a new era of order and efficiency. This revolution allowed electronic devices to shrink dramatically and at the same time to become more powerful than ever. Traditionally, software for designing PCBs was expensive. This high cost created a significant barrier for many people. Enthusiastic hobbyists found it very hard to get started. Small businesses and startups also faced these high costs. Professional-grade tools were often completely out of their reach. This financial limitation unfortunately stifled innovation for a time. Many brilliant ideas could not be easily realized or prototyped. The tools needed were simply too costly for individuals. Then, a new category of tools began to appear: open source tools. These powerful software programs are completely free to use. Anyone with a computer can download them from the internet. Users are also free to modify the software if they wish. This development changed the landscape of PCB design completely. Suddenly, designing PCBs became accessible to almost everyone. Students, makers and entrepreneurs could now design their own boards. This was a truly significant and positive step forward for electronics. The open source movement is built on a core belief. It believes in the power of sharing knowledge and resources. It also champions collaboration among users and developers. This guiding philosophy extends directly to software development. For PCB design, this means powerful tools are freely available. They are often developed and improved by a global community. This dedicated community works together to enhance the software. Users benefit greatly from these continuous updates and support. The rise of open-source PCB design tools is very important. It effectively democratizes the field of electronics design. It empowers individuals and small groups around the world. No longer do you absolutely need a large budget to start. You just need access to a computer and a good idea. This widespread accessibility fuels tremendous creativity. It also drives exciting innovation in many different fields, from advanced robotics to wearable technology and beyond. KiCad is a very popular open-source PCB design tool. It is widely regarded as powerful and highly professional. Many engineers and experienced designers use KiCad for complex projects. It provides a complete and integrated suite of design tools. You can create detailed electronic schematics with its editor. You can also lay out intricate printed circuit boards. KiCad even offers a 3D viewer to see your board. This helps you visualize the final assembled product accurately. KiCad's range of features is truly impressive for free software. It supports hierarchical schematics for better organization. This is very helpful when managing large and complex projects. It comes with a vast library of standard electronic components. You also have the ability to create your own custom components. The PCB editor itself is extremely capable and flexible. It allows for precise and controlled routing of copper tracks. It also includes essential design rule checking (DRC) functions. Fritzing is another excellent open-source option for PCB design. It is especially well suited for beginners in electronics. It is also quite popular among artists and interactive designers. Fritzing makes it remarkably easy to go from a breadboard prototype to a real manufacturable PCB design with minimal fuss. Its graphical interface is very visual and highly user-friendly. Fritzing focuses on making electronics design approachable for newcomers. It successfully lowers the barrier to entry for many people. Fritzing's main strength lies in its inherent simplicity. It features a unique and helpful breadboard view mode. This view looks almost exactly like a physical electronic breadboard. This visual metaphor greatly helps new users understand connections. From there you can easily switch to the schematic view and then finally to the PCB layout view for board design. Fritzing also benefits from a large and active online community. Users often share their projects, custom parts and helpful advice. The very first step in designing a PCB is schematic design. This is like drawing the complete electrical blueprint for your circuit. In the schematic editor, you place symbols for electronic components. You then draw virtual wires to connect these symbols together. The schematic clearly shows how the circuit is intended to work. It defines all the necessary electrical connections between parts. This is a critical and foundational stage in the process. Accuracy here helps prevent many frustrating problems later on. Next in the workflow comes the component placement stage. Here you decide exactly where each physical part will go. This means placing them on the actual circuit board layout. You must think about the physical size of each component and also consider how they will best connect to each other. Good component placement makes the routing stage much easier. It can also significantly affect the circuit's electrical performance. For instance, keeping heat-sensitive parts away from hot ones. Once components are placed, you then do the routing. This important step means drawing all the copper tracks. These tracks are the electrical pathways on the PCB. They connect the pins of the various components as per the schematic. It's like drawing the roads in our tiny city analogy. You need to avoid tracks crossing on the same layer or ensure they are not placed too close together. The design software helps by enforcing specific manufacturing rules. Finally, you prepare your design for manufacturing. You generate a set of special files, usually called Gerber files. These files contain all the data the manufacturer needs. They tell the fabrication house exactly how to make your PCB. Most open-source PCB design tools can create these files easily. You then send these Gerber files to a PCB fabrication service. They will then produce your physical, custom-designed circuit board. Holding your very own design PCB is an incredibly rewarding experience.